take a look at the note packet I gave you. And I'm going to pull mine up here. Okay, so take a look, but keep the blue paper nearby. Don't put that one away. So here's what we have, a parabola. The parabola, I'm going to underline the word parabola here. A parabola is the graph of a quadratic function. And a quadratic function, and put a circle around this one, y equals ax squared plus bx plus c. So the x squared is the key. If you have an x squared in your mind, you need to connect that that's a parabola. A parabola is symmetrical around its axis of symmetry. And the axis of symmetry, if you look right here, it's this dashed line that goes through the vertex. And it'll go through the vertex no matter if it opens up or down. So, for number 2 here, it says circle each function whose graph is a parabola. So, see how many of those are parabolas. Okay, in number 2. So scan through, there's 4 of them. Which ones are parabolas? So we're going to work from left to right, circle all of them that are parabolas. So Alex, what am I looking for? Like, what should I be looking for if I want to find a parabola?
The equation.
And what am I looking for in the equation?
Ax squared plus bx plus c.
Good. And in particular, I need to make sure that I have an x squared. So Jacob, which ones did you circle in number 2?
2 and 3.
Good. The second one and the third one. Now, what do you know about the first one and the last one? We just did this back in chapter 1.
I'm so sorry.
These are of the form y equals mx plus b, so what do they look like? What's the shape of the first one and the last one? Yeah. They're lines, right? Okay, those are lines. All right, now, in number 3, cross out the ones that are not parabolas. In number 3, cross out any of them that are not parabolas. Yeah.
Well, I just thought we were going to answer.
Go ahead, please. Which ones did you cross out?
I did the second one and the fourth one.
Good job. And what was missing that it wasn't a parabola?
It wasn't exponent.
Yeah, it doesn't have the x squared, right?
Yeah.
It does not have the x squared. All right, so now let's look at the next slide. It says describe the transformation of the parent function, which that's the big one that goes through 0, 0, f of x equals x squared. And so that's my parent function. F of x equals x squared. The vertex is at 0, 0. And on my slide, can you see the blue? Okay, that's the one that's in blue. So now, Chris, what happened to the vertex from the blue one to the red one? Where did the vertex go?
Shifted up.
Good. Okay, it's up 3 units. Now, here's what I want you to write down where you have a little bit of space. The vertex is at h, comma, k. H is the left, right, and k is the up, down. Let me say that one more time. This is my general form for a quadratic function. This is actually called vertex form. And the vertex is the h, comma, k. Who would like to give us their equation if you know that that's how it has shifted? It is just up 3, but I didn't go left or right. So what would be the equation here? George, you got it?
What?
The equation.
Let's see, h is height, right?
It's not the height, but it's the vertical up, down.
3, 0.
No, I want an equation for it. we have the vertex went up to 0, 3. It did go to 0, 3. But what's the only thing that has changed?
The vertex.
The vertex. So remember, the vertex is 0, comma 3. So the h is 0 and the k is 3. Julia, what do you think?
X minus 0.
Yeah, x minus 0 squared.
Plus 3.
Okay, now, the thing is, x minus 0 is x, and we're going to assume on this one that the a value stayed the same, that the only thing that changed was that it moved up 3. So when you shift it up 3, that's x squared plus 3. When you're ready, go ahead and flip it. And it says, graphing a quadratic function in the form y equals ax squared. So example 2 says, what are the vertex, axis of symmetry, the maximum, minimum, domain, and range of the function y equals 1/2 x squared? So the transformation is that I have a shrink of 1/2. So the vertex shrinking does not change the vertex. So the vertex is 0, 0. The axis of symmetry is x equals 0. How do we determine if this opens up or down? What do you look for in the equation, Edward?
The negative.
The negative. Awesome. Okay, so out front it's positive, so it's going to open up. If it opens up, that means I have a minimum. The domain is always negative infinity to infinity. And now I need to figure out a table. Well, all I'm going to do is I'm going to plug those numbers in. Now, I personally, here's how I do them. I make a table with 5 values, and I put the vertex in the middle. And if you're sitting there wondering, how did she know that the vertex was going to be 0, 0? I plugged in x is 0. I plugged in x was 0, and then 1/2 times 0 is still 0. That's how I knew. All right, then let's do 1, 2, -1, -2. If you do it this way, where you put the vertex in the middle, you only have to actually compute 2 other points, because then we'll use the axis of symmetry that the other 2 are the same, okay? So if I plug in 1, 1 squared is 1, 1/2 times 1 is 1/2. So that means -1 is the same because of the symmetry. And when we plot it, it might make a little bit more sense. If I plug in 2, watch this. This is y equals 1/2 times 2 squared. Please excuse my dear Aunt Sally or PEMDAS, whichever way you remember it. Do I take 1/2 times 2 and then square? What comes first, multiplication or exponents?
Exponent.
Exponents come first. And what's weird is students will tell me that, but then they multiply first. I don't know why. I'm like, you'll tell me, you do your exponent, and then we don't. So you take 1/2 of 4. What's 1/2 of 4? 2. Use symmetry, so I don't really have to go find the other ones. So let's plot these. I have 2, 2, 1, 1 and 1/2, that's pretty small. So do you see the reason why it's called a shrink is because it's spreading the U shape out. So now once I have this, I do my range when I'm done. That's 0 to infinity. If I go and put the parent function on here just so you can see it, do you see how the parent function is skinnier or that the shrink is wider? And I know that seems a little bit counterintuitive. Like you think, well, you said I'm stretching my arms. I get what you mean when you think that, but what we're referring to is that you're shrinking the y-axis. Instead of it being up at 4 for y, it's now down at 2. That's the shrink. Okay, it's the y value. Okay, so now let's look at example 3 together. It says, what are the vertex, axis of symmetry, the maximum, minimum, domain, and range of y equals negative x squared plus 5. All right, so just looking at this, I should be able to tell where my vertex is. There's nothing with the x, so that's a 0, and the number outside is the up, down. So who wants to tell me? Yeah, Jesse?
Is it 0, 5?
You got it. It's 0, 5. The transformations. What does the negative do out front if you remember what we did with the v's? It opens down. We call that a reflection. And then it's shifted up 5. The axis of symmetry is always x equals the x-coordinate of the vertex. It's going to open down. Well, if it opens down, is there a maximum or a minimum? There's a maximum. The domain is always negative infinity to infinity. All right, I can't do the range and I can't plot it yet till I get some points. So what I like to do is I make 5 lines in my table and I put the vertex in the middle. And remember we talked about this last week before the chapter 3 test, and you guys did a fantastic job on it. The averages were great. I want you to stop and think when you're done, and I recommend you use pencils on quizzes and tests, because I don't have extra copies of tests and quizzes to hand to you if you're using a pen that doesn't erase, okay? I don't mind an erasable pen, that works, that does the job. It's just when you do it in pen and you can't erase it, I can't give you a new test, okay? I don't make that many extra copies for everybody who does that. So use a pencil, but here's my point. If I know this opens down because of that negative and I graphed it and when I got done and my U was up, that should be a red flag for me to go, uh-oh, I made a mistake, okay? Or if it's not making a U at all, I should know I made a mistake. And we go fix it, we go find it. So then I go by ones typically. So let's do, all we need are 2 other points. Then we use symmetry to just fill in the table. So let's do y equals. Now, when you do negative x squared, this is the way that we say negative 1 times x squared. If they meant the negative to get squared, it would look like that. So these are not the same. Okay, and we've talked about this like 5 times already this year when we did our order of operation review at the beginning. So this is not true. Those 2 things are not equal. So I'm going to do negative 1 times 1 squared plus 5. So I'm squaring the 1, which is still 1. So that's negative 1 plus 5, which is 4. Okay, does everybody understand that? We keep going over it, but if you don't ever lean in and figure out what your mistake is when you're doing these, the most common mistake is assuming or inserting parentheses where there aren't parentheses. All right, then the next one is going to be negative, and then I'm taking 2 squared plus 5. So 2 squared is 4, but it's like negative 1 times it. So that's a 1. So here we go. Negative 2, 1, negative 1, 4, 0, 5, and then I just did my symmetry. I do have this imaginary vertical line that is my axis of symmetry. Ooh, who wants to try the range? If the range are the y values, we always start with the smaller value to the biggest value. Who would like to tell us the range on this one? It's a good one, man.
Negative infinity to also 5.
Awesome, good job, okay? So, it's shooting down the smaller value is negative infinity, and it goes up to a y value of 5. All right, when you're ready, flip the page. Okay, this is called vertex form. Vertex form of a quadratic function y equals a times the quantity x minus h squared plus k. So remember, vacuum off and in socks only. Okay, vacuum off and in socks only. Your vertex is the opposite of the inside, same as the outside. So Luke, what is the vertex then of this one? If it's the opposite of the inside, same as the outside. Awesome, 3, -7. Okay, then Sophia, can you describe the transformation for me to this one right here? Is it going left, right, up, down?
Would it be down 7?
Yes.
And then, would it be a
There's no negative out front. The negative out front is the reflection. Remember,
So that would be a
there's no
shred?
no, there's no stretch or shrink because it's a 1 out front. What am I going to do with that 3?
Would it become opposite?
Okay, but which direction? You're right. It's,
Left 3.
no,
Right 3.
it's going to go right 3. Okay, so it is the opposite of the inside. That's the left, right. So because it's a -3, it's going to go right 3, down 7. My axis of symmetry, okay, I finally got something interesting here. This is x equals 3. And then, Brooke, does this one open up or down? How do you know? You're correct. Good job. There's no negative out front. And then, Chris, would this, if it opens up, is there a maximum or a minimum? If it opens up. So imagine your U is up. A minimum. Okay, the domain is -infinity to infinity. All right, then my last step is to do the table. You put the vertex in the middle, and I just go up and down by 1s. That might be a little bit easier said than done. All right, so here's what I'm going to do. I've got room down here. Let's go ahead and do the 4. So I'm going to do y equals 4 minus 3 squared minus 7. So I'm plugging them in. And if you have really good mental math skills, you can do them in your head. It's absolutely fine. I personally do them that way. So 4 minus 3 is 1. 1 squared is 1. 1 minus 7 is -6. Then I'm going to do the 5. 5 minus 3 is 2. 2 squared is 4. 4 minus 7 is -3. So when we're done, it should be opening up with a vertex of 3, -7. So that's sort of what I'm checking here. So I'm going to plot 1, -3. And something I want to mention as we're doing this, if your grid won't fit by going by 1s, then you have to change your scale. They don't literally have to go by 1s. I have students who say, it won't fit on my grid. It's like, then change the scale, okay? Nobody said they had to go by 1s. All right, then use symmetry to get the other side. There is this vertical dashed line, that's the axis of symmetry. And that is hitting right down there. There we go. All right, then David, what would be my range? If the range are the y values, what's the lowest y value it hits? -7, and then it goes up forever. So it's bracket -7 to infinity. All right, example 4. The equation is y equals -2 parenthesis x plus 1 squared plus 4. I'm going to pause a moment and give you about 2 minutes head start on me. And I want you to get as far as you can. Tyra, what did you write down as your vertex?
1, 4.
Okay, remember it's the opposite of the inside. It's always the, yeah, so it's -1, comma 4. All right, who wants to give me their transformations? I see 1, 2, 3, 4 things that need to be said. 4 things. Yeah, Alex, go ahead.
Would be reflection,
Good.
and then left 1 up 4,
Left 1, up 4. What about the 2?
and then shrink.
Nope. If it's
Or
bigger
stretch.
than 1, it's a stretch. If that A value is between 0 and 1, then it's a shrink. My axis of symmetry is always x equals, and it's the x coordinate of the vertex. Okay, this is the x coordinate of the vertex. So, Brooke, does this one open up or down?
Down.
It opens down. So if it opens down, Josh, would it have a maximum or a minimum if it opens down?
Maximum.
A maximum. Okay, the domain is always -infinity to infinity. Now here's the hard part, is getting your table. So I'm going to put -1. Oops. Let me make my table somewhere else here so I can see it better. 1, 2, 3, 4, 5, and I put -1, 4 in. And it does not matter if you have it going 1, 0, -1, -2, -3. It's the same 5 points. Does not matter. All right, so what if I plug in 0? Please excuse my dear Aunt Sally, so you can see the beauty behind what you did in Algebra 1 and what we reviewed at the beginning of the year. Order of operation matters in what we're doing. So, 0 plus 1 is 0. 0 times 0, 0 plus 1 is 1. 1 squared is 1, so that's -2 plus 4, so that's a 2. And then what happens if I plug in 1? 1 plus 1 is 2. 2 squared is 4. -2 times 4 is -8. So then let's plot these. I have -1, comma 4. 0, 2. 1, -4. And then over here I had -3, -4. Ooh, so notice how skinny that one is. And that should make sense because we said it has a stretch. So then I'm going to go back and do my range, which is -infinity up to 4. Hey, did you notice that the range is connected to the vertex? Have you noticed that? The range is connected to the y value of the vertex. If it opens up, it's the vertex to infinity. If it opens down, it's -infinity to the y value of the vertex. That's the connection. All right, when you're ready, let's flip it. Example 5 says determine the vertex and transformation of each function from the parent function y equals x squared, then match the function to the graph. So A, B, C, D, you're going to write the vertex, then underneath the word transformation, you're going to put left, right, up, down, stretch, shrink, reflect, okay? Any of those words. Then, below the 4 graphs, you're going to put the letter A, B, C, D, whichever one it is that goes with that. So let me pause and give you a head start. Do as much of it as you can on your own, and then I'll help you with the rest. If you're a fast worker, go on to example 6 and 7. Do as many of those as you can. While you're working, we will not have any quiz or test this week. The next one I have is tentatively set for Tuesday of the following week. Then that'll be the last grade for the quarter. If you came in after about the first or second week, unfortunately what you see on Power School is not going to be your final grade. I have to take however many weeks out of 9 and do that grade plus what you had from me for however long you were in here. So don't be mistaken if you came in the 5th week to think, oh, now in here you have a 93, but if you had a C or a D in the other course, I have to take 4 9s times that grade plus 5 9s times this grade. So just don't be surprised with how those work out. All right, letter A. Cameron, what did you say for letter A as the vertex?
Left 3, 0.
Okay, it's definitely left 3, so we're going to write it like this. The vertex would be -3, 0, okay? All right, how about letter B? Hannah, what would be the vertex for letter B?
0, -1.
Awesome, 0, -1. Did you happen to get the transformation as well?
Down 1.
Good job, down 1. All right, Theron, what'd you say for letter C for the vertex?
2, 3.
Good job, 2, 3. It's the opposite of the inside, same as the outside. Did you get the transformation yet, or can you do it real quick?
Up 3.
Yep.
2.
Wouldn't it be right 2?
Yes.
Yeah, right 2. Okay, how about letter D? Chris, what would you say for letter D? Vertex.
3, 2.
Oops, we're on D. Sorry.
Oh, my bad.
Yeah, you were on C.
-1, -2.
Good job. -1, -2. So that's left 1, down 2. All right, so now let's figure out which graph goes with which graph. All right. For A, this one has been shifted from 0, 0 to the U is left 3. Hey, that's right here, so I'm going to put the letter A. Which one is, boy, this one, the vertex is right 2 and up 3. Okay, that's C. This one is at 0, -1, so that's B. And this one's -1, -2, so that's D. Do you see how I figured it out? Just moving them. All right, then let's look at example 6 and 7 together. Multiple choice. What steps transform the graph y equals x squared to y equals 2 quantity x plus 2 squared minus 5? So when I'm reading through, and letter A and D say a reflection, do I have a reflection here in example 6? No, right? What would I need to make it a reflection? A negative. So I'm going to cross out A and D right away because there's no reflection. And B, it says stretch by a factor of 2. That's true. But it says 2 units to the right. Uh-oh, it's not 2 units to the right because it's x plus 2. So now the process of elimination, that's C, but it's left 2 and down 5. So letter C. All right, example 7, circle, which one is the graph? Ooh, I like this. When I'm looking at these, which 2 do I immediately knock out?
The ones that are facing down.
Yeah, okay, there's no reflection, so immediately, it's not those 2. All right, now I'm going from, is it left or right? Because they're both down 5. It's left, isn't it? Okay, so that's this first one here. All right, last one. All right, you guys have been fabulous today, okay? You guys have just been really good. This has been a lot of notes. All right, example 8. The graph shows the jump of a dolphin. The axis of symmetry is x equals 2. Uh-oh, what do you know if it's x equals 2 is the axis of symmetry? That tells us something. the vertex, okay? Let's say that one more time. If you know where the axis of symmetry is, that's going through the vertex. So what is the vertex?
2, 7.
2, 7. Now, I've got a point right here. It is at 5, 5. So, vertex form is y equals a times x minus h squared plus k. The h and the k are from the vertex. And then the 5, 5 is the x and the y. So label it, okay? Label it. Everywhere you see I've labeled, you label your paper, because this is going to help you on one of the homework problems. So guess what? I know h, k, x, and y. What's the only letter missing then? A. If I know a and hk, I can write the equation. So here we go. Y is 5, x is 5, h is 2, and k is 7. Hey, I know how to solve this for one unknown. Okay, we're good to go with this. 5 minus 2 is 3, and then I square it. So that's 9a plus 7. Subtracting 7, I get negative 2 equals 9a. Divide by 9, and a is negative 2, 9. So watch this. This is awesome. We just solved for a, and we know the h and the k. So all you do is plug in a, h, and k, and there's your equation. Your equation needs an x and a y in it. So this is y equals negative 2/9, and that makes sense because the parabola is opening down. X minus 2 squared plus 7.